Okay, now we're going to do not just the setup, but the entire partial fraction decomposition. So it goes like this. Number 7. This came to us factored. Very nice. This is going to be something over x minus 2 plus something over x minus 5. And so 1 less than 1 is just some constant, just like that. Okay, so now let us go ahead and we have to solve for a and b. So it goes like this. The first step, of course, is to factor if it's not factored. The second step is to set up your decomposition. And then the third thing to do is to solve for a and b. So what I'm going to do is multiply both sides of this equation by the lowest common denominator. You don't ever have to worry about trying to figure that out. It's always going to be this right here, x, whatever this denominator is. So just to make some more room, let me erase that for a second. X minus 2 times x minus 5 on this side. X minus 2 times x minus 5 on the right side is legal. I have balanced my equation. So when I multiply the left side times x minus 2 and x minus 5, these will divide into these, giving me just ones. What's left on the left is negative 4x plus 1. On the right, this will distribute to both terms. And what's going to happen here is these guys will cancel. I'm left with a times x minus 5 plus, when it distributes here, these guys will cancel. I'm left with b times x minus 2. All right, so I'm going to work on this right side. This is equal to ax minus 5a plus bx minus 2b. I still have negative 4x plus 1. Now, what I'm going to do is collect like terms. I have an ax and a bx. Ax plus bx. And then I have, these don't have any x's. Those are like terms. Minus 5a minus 2b. So now, what I'm going to do is factor out the x from these two terms. So what that looks like is I'll have x times a plus b. And I'm just going to put a parentheses around these. Minus 5a minus 2b. And this is equal to negative 4x plus 1. Now the next thing we do is we set up a system of equations. And we do that by equating coefficients. We say this coefficient of the x is equal to this coefficient of the x. So that looks like this coefficient of the x, negative 4, is equal to this coefficient of the x, a plus b. And this constant term, 1, is equal to this constant term, negative 5a minus 2b. And so for my comfort level, I want my numbers on the other side. I'm going to say equals negative 4 equals 1. And that's called the reflexive property. You're allowed to do that. If a equals b, then b equals a. That's what that is. Okay, so now I'm just solving this system of equations. We've learned many methods of how to solve a system of equations. I'm just going to use adding equations together because this is a little baby one. It's not a big one. So I'm going to multiply the top equation by positive 2, which gives me 2a, I'll rewrite it down here, 2a plus 2b is equal to negative 8. And I chose to do that because when I add the b's, they'll be eliminated to 0. So negative 5a plus 2a is minus 3a is equal to 1 plus negative 8. Let me check real quick. I think it turned out I got a different number when I did this earlier. Hang on. Am I missing a negative somewhere? Am I missing a negative somewhere? Hang on. Oh, maybe on the sheet this is negative 1. I had this as a negative 1. I might need to go fix this for you guys. Is this negative 1? All right, let me just check. Okay, I think that's supposed to be a negative 1. Anyway, so we're going to say that if that is, then that's negative 9. And then we'll divide both sides by negative 3. And we'll get that A is equal to 3. Okay. Now, once you have a number for A, then you plug it in to any equation that you want to solve for B. I'm going to choose the top one and say that 3, I'm going to replace A with 3 plus B is negative 4. And if I solve for B, I'll subtract both sides by 3. I'll get negative 7. So let me see what I did here. That I changed it to negative 1. And let me make this change on my worksheet so that you get the right thing. This is a negative 1. Okay, cool. That's that one. Let's do number 8. The setup is rewrite this into its the template setup. So for number 8, we're going to rewrite this into something over x plus 3 plus something over x plus 3 to the second power. All right, that's the setup. What goes in the numerator is a constant, and what goes in the numerator is another constant. Okay, so just to make some more room, I'm going to erase this other part. The next thing is you multiply both sides by the lowest common denominator, although you don't have to worry about what that is. It's always this guy right here. What I find is helpful, though, is when you have a term being squared or repeated, it helps me to write it out 2 times. So I'm going to do that. I'm going to multiply this side by x plus 3 times x plus 3, which is the same thing as x plus 3 squared. I'm going to multiply this side times x plus 3 times x plus 3. Okay. What happens when we multiply on the left is x plus 3 times x plus 3 divides with x plus 3 times x plus 3. So we have just x minus 7. On the right side, this will distribute to both terms. So when we multiply a over x plus 3 times x plus 3 times x plus 3, one of these gets canceled, and we're left with a times x plus 3. Plus what happens here is both of these get canceled, plus b. All right, we distribute the a. This is ax plus 3a plus b. This is x minus 7. Then we set the coefficients equal to each other. We equate coefficients. The coefficient of the x term here is a. The coefficient of the x term here is 1. So a is already solved. That's really easy. The coefficient of, the constant term here is negative 7. And the constant term here that doesn't have an x next to it is 3a plus b. Well, if a is already 1, we'll just substitute that in. 3 times 1 plus b is negative 7. I subtract 3 from both sides and I get b is negative 10. All right, so I forgot to finish number 1. This is not completely finished, so shame on me. I'm going to finish it real quick. This is the final answer that I should write down. I got that number 7. I got that a was 3 and b was negative 7, right? This right here, when you replace a and b with what they are, you figured out that they were, this is the final answer. This is the partial fraction decomposition. So that's the final form I'd like to see it in. So right here, I'm going to do it on this one. X minus 7 over x plus 3 squared is equal to, I'm going to write the final form, a 1 over x plus 3 plus b negative 10 over x plus 3 squared. This is a good way to write this also. This is acceptable. If I said minus this, that's the same thing. Okay, let's do number 9. Setup is going to be something over x minus 3 plus something over x plus 2. It's repeated. Plus something over x plus 2 to the second power. That's the setup. A, B, C. Multiply both sides of this equation by the lowest common denominator, which is this right here. I'm going to multiply this by x minus 3 times x plus 2 squared over 1. I'm going to multiply this side times x minus 3 times x plus 2 squared. Sometimes I think it's better to write that out twice. Now, it's going to distribute to each term. So It's getting kind of crowded, so I'm not going to write this down 3 times. I'm just going to say it out loud. On the left-hand side, x minus 3 times x plus 2 squared over 1 times this over x minus 3 times x plus 2 squared. This will divide into this, giving me just x squared minus 3x plus 5. On the right, a over x minus 3 times all of this. Just the x minus 3 will cancel. I'm left with a times x plus 2 squared, which is x plus 2 times x plus 2. All right. B over x plus 2. What's going to happen here? Only one of the x plus 2's gets canceled. So we're left with B times x minus 3 times x plus 2. Okay, great. What about the last one? C over x plus 2 squared. What's going to happen here is this wipes out 2 of these, and I'm left with C times x minus 3. The rest of this is a bunch of algebra, so let's just do all the algebra. First, before I distribute the A, I'm going to multiply this together. So x minus 2 times x minus 2 is x squared plus 4x plus 4. X minus 3 times x plus 2 is going to be x squared minus 3x plus 2x minus x minus 6 plus c times x minus 3. Okay. I'm going to distribute the A. This is A, x squared plus 4ax plus 4a plus b, x squared minus bx minus 6b plus cx minus 3c. Let me see if I'm happy with that. Ax squared, 4ax, 4a, bx squared minus bx minus 6b, cx, 3c. Okay, now I'm going to group like terms together. What's on the left? Same thing. This is the whole way. We haven't done anything to the left-hand side. All right, on the right-hand side, let's put like terms together. We have an x squared. This time I'm going to factor out the x squared as I group. This will be x squared times a plus b plus an x times, where are my x terms? I've got 4ax, yep, negative bx and cx, and that's a plus. Okay, so this is going to be 4a minus b plus c. Okay, great. And then where's my constant terms? They're right here. 4a minus 6b minus 3c plus 4a minus 6b minus 3c. All right, let's set up our equations. Equate coefficients. So I've got a plus b is the coefficient for the x squared term. A plus b is equal to 1. Then I've got 4a minus b plus c is equal to negative 3. And then I've got 4a minus 6b minus 3c is equal to 5. Now, I want to make sure I didn't make a mistake, so I'm going to look at this over real quick and see if I agree with my equations I set up. I said a plus b is 1. 4a minus b plus c is negative 3. 4a minus 6b minus 3c is 5. Okay, I like that. Now, this is not a little bitty 2x2 equation. This was not something that just the answer popped out. So I'm going to use matrices to help solve this. I'm probably going to put it in RREF form. So I'm going to form an augmented matrix. The coefficient matrix, 1, 4, 4, 1, negative 1, negative 6, 0, 1, negative 3. I'm going to augment it with my solutions matrix, 1, negative 3, 5. I'm going to put it in my calculator. I'm going to use RREF and see what pops out. And what will pop out is the reduced row echelon form of the coefficient matrix. And then what A, B, and C should equal to right there. And when I did this, let me make sure I'm on doing number 9. Yeah, I'm doing number 9. When I did this, I got 1/5, 4/5, and negative 3. 1/5, 4 over 5, and negative 3. All right, so what is my final answer? My final answer is, this is what A is, this is what B is, and this is what C is. A is 1 over 5. B is 4 over 5. C is negative 3. And of course, these are not slashed out. These are x plus 2 squared. All right, so this is your final answer. Now, there are alternative ways to write this, so let me show you other ways that you can see this are completely correct. The first thing we already talked about, where if I don't want to write, if I have a negative number, I can just call this minus 3 something. That is acceptable. But what happens when you have a fraction over a fraction? This denominator 5 can be put right here. This is equivalent. This denominator 5 can be put right here. So this is another acceptable answer for a number when you have those kind of answers. Okay, last one, we'll take a little break, and I'll do the last two on a separate video. Number 10 is this right here. So let me make some room for number 10. Got it written down, so let's do it. So go ahead and start the setup. And so when you set this up and you look at that, if you try to factor x squared plus 5x plus 7, cannot make it, you can't, let me just say this for the record. Every single thing is factorable with imaginary numbers and irrational numbers and all kinds of stuff like that. When I say factoring, I mean with whole numbers, okay? So this is not factorable with whole numbers, so we'll leave it like that. We'll work with that. That's fine. So here we go. I'm just going to copy it down so I've got more room. We're writing the partial fraction decomposition for this expression. Okay, the setup's going to be something over x minus 3 plus something over x squared plus 5x plus 7. All right, I like it. So here's the deal. What goes in the numerator is something of 1 degree less than what's in the denominator. So we look at the first term, x plus 3. This is degree 1. So we have to put something of degree 0 or a constant in the numerator. I choose A. You can choose different letters if you want to. It's fine. Then, this is of degree 2. So I have to put something of degree 1 or linear in the numerator. Bx plus c. All right, the setup's done. Now we're going to kill our fraction by multiplying both sides by denominator. The denominator is x minus 3 times x squared plus 5x plus 7. X minus 3, x squared plus 5x plus 7 on both sides to keep your equation balanced. These divide into each other, giving you a 1. We're left with 2x squared plus 3 over here. Over here, the x minus 3 cancels with the x minus 3. I have an a times x squared plus 5x plus 7. Right here, x squared plus 5x plus 7 cancels with this, and I have bx plus c times the x minus 3. All right, let's just multiply everybody out and see what happens. This is, let's see, this is ax squared plus 5ax plus 7a. Bx times x is bx squared. Bx times negative 3 is minus 3bx. C times x is cx. C times negative 3 is negative 3c. So now, let's get our like terms together. X squared, what goes with him? A plus b. X, what goes with the x? 5a minus 3b plus c. What is my constant term? 7a minus 3c. All right. Let's write down, let's equate coefficients. The coefficient of the x squared term is a plus b. The coefficient of the x squared term is 2. The coefficient, or the number in front of the x over here, is 5a minus 3b plus c. The coefficient of the x term, there's no x term, so his coefficient is 0. The constant term, 7a minus 3c is equal to the constant term over here, which is 3. So if I were to say, write the matrix equation, which I will ask you to do. Let's just do it in this case. Here's the coefficient matrix. 1, 5, 7. 1, negative 3, 0. There's no b term. 0, there's no c term in the first equation. 1, negative 3. This is the coefficient matrix. The variable matrix is a, b, and c. And the solutions matrix is going to be 2, 0, 3. Now, you can solve this by Kramer's rule. You can solve this by RREF. You can solve this by inverse matrices. That's totally up to you. I'm going to use RREF. So I will use my calculator and put in 1, 5, 7, 1, negative 3, 0, 0, 1, negative 3. Augment it with the solutions. Put in my calculator and it's going to spit out the RREF. And what I get for this one is, let's see, we're doing number 10. This one gives me some fractions. So I want fractions. So if your calculator is kicking out decimals, you need to hit math, enter, enter, and that will transition it to fraction form. So right here, this is going to be 21 over 31. 21 over 31. This is going to be 41 over 31. 41 over 31. This is going to be 18 over 31. 18 over 31. How do we write our final answer? It's supposed to be A, 21 over 31 divided by x minus 3. Plus B, 41 over 31 times x plus C, 18 over 31 over x squared plus 5x plus 7. Again, we can rewrite this with the 31 in the denominator. So this could be also written as 21. And put the 31 right there. We could rewrite this as, put the 31 down here. And this would be 41x plus 18. This is also a good answer for this one. But rewrite it with the A's and the B's and the C's replaced. Okie dokie. I'm going to stop this one and do the last two on a separate video.